Hello all, welcome to another quick learning. Today we're going to be going over t-tests in Google Sheets. So first of all, why would you want to do a t-test? That's because you want to compare the means of two different conditions that you have. One of the big things that you might use this for is A/B testing with websites. So let's say you change the color of the buy button to red. You want to see how that might impact sales. So you would randomly select different users to be in one of the two different groups, either the original color of the buy button or the red color of the buy button, and see if their sales are affected. So I created just some sample data. So using the norm_inv, the rand function, and using this mean and this standard deviation that I put on the top, I created some random data. So you can see that I've set it up so condition 2 actually has a higher mean than condition 1. So our t-test, if we have enough statistical power, should show that they are different. But we're only using 10 tests, so the power of our t-test is not going to be very large in this case. So to do a t-test, first thing you do is you go equals, and then the t-test function. And then we're going to do a range. So we're going to select the range for our first condition, and then the range for our second condition. And then tails. So tails specifies the number of distribution tails you want to use. If you're only looking at a one-way t-test, so if you're only interested if the condition improves the mean or decreases the mean, then you would choose one tail. If you want to see kind of the absolute change, whether it be greater than or less than, then you would choose two tails. If you choose two tails, then the p-value will just be double what the one tail one is. We're going to go ahead and choose one tail because we're only interested if condition 2 increases the mean over condition 1, because if the red button doesn't increase the sales, we're not going to move to it. And then the type, so I'm going to close this out. And so the type is either 1, 2, or 3. For 1, it's a paired test. What is meant by a paired test is you can pair the data from condition 1 and condition 2. Let's say we had a training regimen that we thought would improve the performance of a runner. We could test them before they had the training regimen, and then after the training regimen we could test them again and see if the average running length time changed. 2 is if you have a 2-sample equal variance, and 3 is if you have a 2-sample unequal variance. So if you don't know if you have equal variance or not, then the best case is to choose 3 and assume they're not. And you can see here's the p-value, and what is meant by the p-value is what is the probability that these two different conditions have the same mean. So this says that the probability is very low that they have the same mean, and in fact they do have different means because we set it up that way. So this is very good evidence in this p-value that these two means are different. Now if I change this mean down to 5, you'll see the p-value goes up significantly. And usually we use a threshold of 0.05, so 1 in 20, that you would be wrong if you thought that the means were different. And you could give it more statistical power by increasing the number of samples. It will also be more difficult for the t-test to figure it out if the standard deviations are higher. We'll just do it again. So this is going to calculate. So you can see the p-value actually went down when I increased the standard deviation. In most cases it will go up, but because we're doing random distributions, it's hard to tell. Let's increase this one to 3 too. You can see the p-value really goes up there. Now if we actually start making them different by a little bit, you can see the p-values start to go down. And then if we increase the number of samples, so let's go to 21 samples, and we have to change this as well. So we're going to delete this and select the new range. Because there's more samples, there should be more statistical power, so it should be able to find that difference more easily. Let's see what we got. So we're still pretty low, but let's decrease the standard deviation here. And now you can see that p-value is starting to go down again, and if we increase the samples even more, we could probably make it so that the p-value will be below 0.05. Let's just really up the number of samples to 65. Let's go here. Right. And we'll change this to 69 as well. You can see now the p-value is very low. So it can find that these two means are different because there's enough samples. So that's one thing to take in mind. Make sure you have enough samples in order to make sure you will find a difference if there is one. And if the standard deviation of what you're measuring is very high, then it's going to be even more difficult and you're going to need more samples. Or if the means are very close together, you're going to need more samples in order to resolve that difference. All right, thank you very much. I hope you guys learned something. And now you can use t-test to check whether two different conditions have a different mean. Thank you very much.